All right, picking back up here. Now we're talking about the last two methods where we're going to factor in the time value of money. So some things that we need to consider. We need to know the principal amount, so the amount that's invested or the cash flow or whatever. We need to know the time period, so how many years is generally what we'll do, and the interest rate, or in some of these cases we'll call it the hurdle rate. So I'm going to show you the basics and how to use the tables. And so we'll have just a couple practice problems with that, and then we'll use what we've learned to analyze, go back to the ski park lodge thing and do that. And you apply what we've learned to analyze the project. So there's two ways that the money can come in or go out. It's either a lump sum, just a one-time thing, or it's an annuity, which is the same amount at the same time each year. So we assume the money is coming in an even stream. It's always, the end of the year, the beginning of the year, or the same type of thing. We can use the tables two ways. We can look at the future value of some present amount. So I can say, if I invest $1,000 now, how much is that going to be worth in the future? Oh, it does this every time, doesn't it? Or I can look at the present value of some future amount. So I can say, if I get $1,000 10 years from now, what's that worth in today's dollars? And so you're taking some future cash flow, either a stream of cash flows, annuity, or a lump sum, and saying, what is that worth today? Or you can say, here's the amount of money I know it is today. How much is that going to be worth in the future? And so the tables will work both ways. There are four tables that we're going to use. Table 1 is the present value of $1. And this tells you today's value, what it's worth today, of a future lump sum. If I received $1 or $1,000 or $10,000 at some point in the future, what is that worth today? Table 2 does the same thing but for an annuity. So present value of an annuity tells you the value in today's dollars. So today's value of a future stream of cash flows, an annuity. And then table 3 is the future value of $1. So what will today's lump sum be worth at some point in the future? What will $1 today or $1,000 today or whatever it is? So what will today's lump sum be worth at some point in the future? And then the fourth one is basically the same thing. Future value of an annuity. What will a stream of cash flows be worth in the future? And so this is how I can compare projects of different time frames. I'll bring it all into today's dollars or all into at some point in the future. So I'm comparing apples to apples, and I think you'll see what I mean. So this is table 1. This is the present value of the dollar. So I would use this one. For example, if I receive $100,000 5 years from now, and I'm assuming an interest rate of 5%, what would that be worth? Oops, sorry. Just trying to make that a little bit neater. So I would go with, here's my 5%, and I would go with 5 years, and I would see where they meet, and this gives me, oops, nice. 0.784 is my discount factor, okay? This is my discount factor is what I call it. So I would take my $100,000, my future lump sum, times the discount factor, 0.784, and I get $78,400. What that means in English is receiving $100,000 5 years from now is worth exactly the same as receiving $78,400 now. That's what that means in English. Present value of an annuity. So this would be if I receive, instead of a lump sum 5 years from now, if I receive $20,000 per year each year for the next 5 years, and I'm going to use that interest rate of 5%. So I do 5% in 5 years, and it goes this way, and I get 4.329. So I take my annuity amount, my annual cash flow of $20,000, times the discount factor of 4.329, and I get $86,580. So that tells me receiving $20,000 a year every year for the next 5 years is worth exactly the same as receiving $86,580 today. And you can see that even though they're both $100,000 total, this one's worth less because you have to wait longer to get it, right? Oops, wrong way. This one, at least I'm getting some of the money up front where it's worth more. And so that's why this one has a higher value, even though they both total the same. The more you get up front, the more it's going to be worth because you're losing less over time. The future value table, this one would answer you if I invest, what do I have, $20,000 now at 6%, and I let it sit there for 10 years. What would it be worth? So I take the 6%, and I would take the 10 years, and I follow that over here, and I get 1.791. So I would take my $20,000 that I'm investing, my one-time lump sum, times 1.791. I'm assuming I'm earning 6% interest for 10 years, and so I would get $35,820. If I take $20,000 now, let it sit there at 6% for 10 years. In 10 years, I will have $35,820. That's what the future value tells you. And then the last one is the future value of an annuity. If I invest $5,000 per year, oops, I can't spell, $5,000 a year for 10 years at 6%. Again, 6%, 10 years, 13.8 or 13.18. So I take my 5,000 times 13.18, and that will be worth $69,100 at the end of 10 years. So that would be like, I don't know, you've got a Roth IRA and you're putting in a certain amount every single year. At the end of 10 years, that's what you would have. So that's what each of the tables are. Feel free to rewrite that in your own words, what they mean. But now, so we've got two practice problems here where we look at what this is worth, and then we will go back to our Snow Park Lodge. So for this guy, what we're going to do is we're going to take the present value of $1, right, which is table 1, and we're going to use a 12% interest rate. And we're going to say, all right, so we'll set it up like this. So here's my time, right? Year 1, 2, 3, up to 5 years, 4, 5. And then my cash flow in each of these would be $1. Then I'm going to take that times the discount factor. The discount factor I'm going to get from table 1, and I'm going to look at 12%. And so let's go back to table 1 here. At 12%, in year 1, the discount factor is 0.893, 0.797, 0.712. So these guys right here, Table 1, 12%, years 1 through 5 is what I'm going to copy over here, okay? So I'm taking these straight off of Table 1, the 12%. So the discount factor for 1 year is 0.893. For year 2, it's 0.797. And it will keep getting smaller, right? Because the longer it goes, the less it's worth to me, right? Because of all those, the risk and the loss of purchasing power and the opportunity cost. 636. And so each year, that dollar is worth a little bit less in today's dollars, 67. Now, if I take the cash flow times the discount factor, that gives me the present value. So what that says is a dollar received 1 year from now is the same as receiving 89.3 cents today. A dollar received 2 years from now is the same as receiving 79.7 cents today. And again, this is easy because it's a dollar, but any cash flow you would fit in, you would do the exact same process. 0.712, 0.636, and that dollar that I receive 5 years from now is worth 0.567 cents in today's, 56.7 cents in today's dollars. If you added those up, you get 3.605. So receiving $1 a year for the next 5 years is the same as receiving $3.60 today. Okay? That's what that means. So $1 a year for 5 years equals the same as getting $3.60 now. This is an annuity, right? It's the same amount every single year, so that's an annuity. So that means I could use Table 2, which is the present value of an annuity. Now if I go to Table 2, this is 12%, and this is 5 years, and the number is 3.605, which is the same thing we got here, right? So if I take the dollar times the discount factor of 3.605 from Table 2, I get 3.605. And the point of this problem is to show you that Table 1 and 2 are the same thing. Table 2 just takes Table 1 and adds it up for you. So if you go to any point on Table 1, right, here's the factors for this one. In Table 2, at 2 years, it just adds these two. And at 3 years, it adds the first 3. And at 4 years, it adds the first 4. And at 5 years, it adds the first 5. So it's just summing these up for you so that, and that's what you can see right here. It just sums them up. This is just the sum of what's in Table 1, summing that column up. So that if you have an annuity, you don't have to do each year separately. You can just pop straight to this one. So that's what that one shows you. The next one I think is a fun problem because you're getting money. So your grandfather would like to share some of his fortune with you. You could use the same thing if you're doing, if you win the lottery. Okay, so let's say you won the lottery, you could do the same thing. So if your grandfather, he gives you money in 3 options he's giving you, and you can choose the one. So we want to give the one that gives us the highest total value. So you can get $85.50 per year for the next 7 years. So if I take $85.50 times 7, that's a total of $59,850. So basically your choices are $59,850 spread out over 7 years, $48,350 now, or $100,250 7 years from now. So the only way for me to compare these is to bring them all into the same time frame to see which one's really worth more. So I'm going to use an 8% discount factor. For this one, it's an annuity, and I want the present value of a future stream. So present value of an annuity is Table 2. This one's already in today's value because that's now. This one is a lump sum. So present value of a lump sum or a dollar, that's Table 1. So that's what I'll use there. So I'm going to take the cash flow. So let's see, I'll have option 1. I'm going to take the cash flow times the discount factor to get the present value. So the cash flow here is 8550, and I'm going to go to Table 2, and I'm going to look at 7 years and 8%. So if I go to table 2, 8% and 7 years is this guy right here, 5.206. So that's what I fill in here, times 5.206, and I get a present value of $44,511, which means receiving $85.50 a year for the next 7 years is the same as receiving $44,511 now. Option 2, I don't have to do anything. That's already in today's value, or today's dollar, so that's $48,350. You can already see that option 2 is better than option 1 because it's worth more. Option 3, I'm going to take the $100,250, and I'm going to go to table 1, 8%, 7 years. So if I go back to table 1, 8% and 7 years, that is right here, 0.583. So I'm going to put 0.583 in here, 0.583, and I get $58,446. So receiving $100,000 7 years from now is the same as receiving $58,446 now, and that I can see is my best option, right? Because that's worth more. So I'd be better off waiting for the higher amount. Now, part 2 says, would your preference change if you use a 12% discount rate? Now, a higher discount rate would indicate either more inflation or a higher opportunity cost, like maybe interest rates are higher, and so the interest that you could be earning is more, and so in either way, it's going to change it. So in one, again, I'm going to take the cash flow times the discount factor to get the present value. So 8550. I'm still going to use table 2, but now I'm going to go at 12% and 7 years. Table 2, 12%, 7 years. I get 4.564. So you can see it's worth less. My discount factor has gone down. It's worth less than it was before because either it's buying me less in purchasing power or I'm giving up more interest or something like that. So for this one, if I take 8550, my discount factor, my new one at 12% is 4.564. So the present value of that future stream of cash flows is 39,022. It's worth less. Option 2 is still already set for me, 48,350. That is today's value. I feel like QVC, like today's special value, but all right. The third one, 100,250 at 12%, 7 years from now. So I go back to table 1, 12% and 7 years is here, 0.452. So again, that has gone down. Higher opportunity cost, more inflation, whatever. 452 means this is now worth 45,313, which means because of that, now choice 2 is your better option. You might as well take this. Waiting is not worth it anymore. So the discount factor that you pick can definitely influence your answer here. All right. So using what we know with these tables, we can use this to analyze the cash flows of a project. And so I can take all these future cash flows, bring them out to today's value, and compare that to the money I'm putting out today. So what is the future cash flow? What is that worth today compared to what I'm spending today to see if this project is what kind of return I'm getting. So I'll need a discount rate. This will be my required rate of return, or my hurdle rate. And I'm going to use this to reduce all future cash flows to today's value so that I can compare apples to apples. to today's value. I'll need, if there's a residual value, I can just treat that as a lump sum in the final year of the project. I just treat it like I'm selling off this thing and getting that much cash at the end. If I have equal cash flows, again, just like with the payback, it's pretty easy. I take the present value of all those future cash flows, and to get that, I would use Table 2. My annual cash flow would be the annuity amount, the even amount, and I would use Table 2 to discount that. I subtract off what I paid today, the initial investment, and the difference is my net present value. If I have uneven cash flows, it will look a little bit different. So I could do my cash flows like this: year 1, 2, 3, 4, 5. Do what the cash flow is times the discount factor will give me the present value. And so I could do 10,000, and let's say I had a whole bunch of different cash flows, but I netted them all together, right? And then this year it's 8,000, and this year it's 8,000, and this year it's down to 5, and then I sell it off here, and I've got my lump sum, so I'm up to 15 here. I'm just making those up. Then you would use Table 1. So whatever your discount factor is at year 1, so this would be, I'm making these up, 0.986, 0.812. I'm making all these up. Like that, made up numbers. You're not going to find these in one of those tables. And then you would just take that, and so that's going to give you your present value. And then you add all these up. So you've got all these present values of each of these future cash flows. These are all made up. So this will give you the total present value of all your future cash flows. Then you subtract off your initial investment, and that gives you your net present value. Now, there are a couple things here that's important to remember. Look, I'm going to switch to red because it's important. Okay, a net present value of 0 does not mean that you are breaking even. Present value does not equal your profit. If you get a present value of 0, what that means is that the return on this project equals exactly the hurdle rate you put in. So if I was using 12% and I get a 0, that means this project is returning exactly 12%. If you get a positive net present value, that is not the amount of money you're making. That just means that the return on this project is greater than the hurdle rate. If you get a negative net present value, that does not mean you're losing money. That means that the return on this project is something less than the hurdle rate. So that's kind of important. I mean, I think a lot of people see that and think that's how much you're making, and it's not. That just tells you the difference. Now, this doesn't tell you exactly what the return is. That's what the IRR is that we do in the next one. So we're going to go back to the Snow Park Lodge and do the net present value. This is an annuity, so this one's pretty easy. So we'll just take the present value of an annuity, which is my net cash flow, right? So the cash flow is $2,687,256 per year. I'm going back to that original problem that we did. That's an 8, sorry. Times the discount factor. Now we're going to use Table 2 because it's an annuity. They told us in the original that it's 12%, and it's 8 years. So if I go back to Table 2, and I've got 12% hurdle rate and 8 years, I've kind of drawn over that one. I've got 4.968 is the one I want to use right now. times 4.968. That will give me the present value of those future cash flows. So in this case, that is $13,350,287. So that extra cash flow of $2.687 million a year for the next 8 years is worth $13,350 in today's dollars. If I take the present value of the residual value, so at the end of it, it's worth $600,000, which is what they told us. That's going to be table 1. Table 1, and I'm going to use the 12% in the 8 years. And say, all right, getting that $600,000 at the end of this, at 7 years, is going to be worth, that's 0.404 right there. 12% in 8 years. So I discount that and say, all right, getting that money at the end, let's say I'm selling this off, 0.404 is worth $242,400. Add those two together, 13,592,687 is the total present value of all of my future cash flows. Okay, subtract off that initial investment. In order to create this positive cash flow, I had to spend $11 million. So that gives me the net present value of this project is $2,592,687. 592, sorry. Which means this is well above that 12% hurdle rate. The closer you are to zero, the closer the return is to the hurdle rate. So if this came out to be like 1,000, then I would say it's pretty close to, it's over 12%, it's pretty close to 12%. The fact that the net present value is 2.5 million means this is probably pretty far above the 12% that I put in there. I'm going to do one more here that just shows you uneven cash flows. This is not related to the snow park lodge. So in this one, some company called Castle is considering an investment opportunity with the following expected net cash inflows. So they've already netted out the money coming in, the money going out. So we've got 3 years, 3 different cash flows. 9% discount rate, initial investment of $345. Calculate the net present value of the investment. So year 1, 2, 3. I'll take my cash flow. So it's 230 in year 1. It's 170 in year 2 and 110 in year 3. Then I'm going to need my discount factor. And I'm going to use table 1, and I'm going to use 9%, and I'm going to take the discount factors for year 1, 2, and 3. And then that's going to give me the present value of those future cash flows. So if I go back to, I know it's a lot of flipping, I'm doing 9% now. So it means I'm going to take 9.917 for year 1, 0.842, and 0.772. So those are the ones I'm going to plug in to here. So 0.917, 0.842, and 0.772. So that gives me a future value of that first year's, a present value of that first year's cash flow of 210,910. The year 2 cash flow is worth 143,140 today, and the year 3 cash flow is worth 84,920 today. So I add those all up, and I get 438,970 is the present value of all the future cash flows. Subtract off that initial investment, which is 345. And so the net present value of this project is 93,970. And so they should either go ahead and invest or at least pursue this further, depending on what else they got, because it returns at least their 9% goal. So that's what it looks like with uneven cash flows. All right, last thing. Internal rate of return is our last thing. So what we said in net present value, if we get a positive net present value, that says that the project is returning something higher than the hurdle rate. So IRR tells you, all right, what is it? So basically, you keep going until there's if you were to keep changing that net present value until you came to zero, keep changing the hurdle rate until you get a net present value of 0, that is the internal rate of return. If it's equal cash flows, again, it's like anything, it's much easier. So you've got 2 steps. You take the initial investment divided by the annual cash flows, and that's going to give you a discount factor. That's not your answer. Not the answer. If people mess up, it's because they stop here. Then you find that discount factor in your table. Find discount factor in table 2. So this would be an annuity, table 2, for that time period. So you go to the year until you find that, and we'll do one. If it's unequal, you can do this thing called interpolating, which I'm not going to make you do here. It's a real pain. Or you can just kind of keep recalculating net present value with different discount rates. Until the net present value is 0. If you had it in Excel, that's not really all that bad, because you can just keep changing the thing. We will not have to do that in this class. If you take managerial accounting or intermediate or something like that, we'll get into that a little bit more. But for this class, we'll just do even cash flows. So for this one, we're going back to our other one. We're doing no residual value, so we don't have to do that lump sum at the end, which is good for us. What is the IRR? So again, we take that initial investment divided by those net annual cash flows. So I get 11,000,000 divided by 2,687,256. And I get 4.093, which, by the way, was also our payback period, right? 4.1 years. So I take that, and now I need to find this one. Find in table 2, looking along 8 years. All right. So, oops, sorry, wrong one. Keep that. Sorry, I got a little ahead of myself. All right, so let's go back to table 1. I know I go a lot of flipping in this one. I hope I'm not making your car sick. Oops, not too far now. I'm going crazy. Okay, table 1, and I'm going to go along 8 years. I am looking for 4.093. So I follow along 8 years. I'm sorry, that's table 2 because it's an annuity. 4.093. 8 years, I keep going along. I'm getting close. It looks like this is too far. 18 is too far. So it's somewhere here between 16 and 18. All right? So these are the 2 that's relevant. This has gone just a little bit too far, but that's pretty close. So if we go back here, trying not to go too far again, at 16, is 8 years at 16%. The discount factor was 4.344. I'm just taking that off the table. 8 years at 18% was 4.078. And so we can see our number would fit in right about here, right? 4.093. So the answer, all they'll ask you for for this course is say it's between 16 and 18%. That's the answer to the question. But we can say here, we can see that it is much closer to 18 than 16, right? So I would say it's almost 18%. And there are ways mathematically where you can get that and you could figure out that it's exactly 17.4% or something like that. But we don't need to go that far. But we can see, along here, it's not in the middle and it's not close to this one. It's very close to 18%. So that's how you read that. Okay, so there's chapter 26, and that's our last video. We're all done, and I hope you've had a great semester.